This is Libby, and today I'm going to be talking about rates of reactions with enzymes. So, what are the factors affecting the rate of enzyme action? The factors that affect the rate or the speed of enzyme action are, first of all, temperature. Increasing the temperature of a working enzyme initially increases the reacting activity. Enzymes have an optimum temperature, and this is where they work at their best, but once this temperature has been reached, the activity begins to decrease. Past a certain temperature, the active site changes shape and the enzyme is denatured. This means it loses its catalytic activity, or its ability to bind to the substrate and catalyze its reaction. The second factor which affects the rate of enzyme action is pH, or a measure of acidity. Enzymes also have an optimum pH, which is where they work at their best. If the pH changes away from this optimum, either by increasing or decreasing, then the enzyme activity decreases. If the pH is too low or too high, then the enzyme is denatured and will not function. So as we just mentioned, when the pH is very high, enzymes denature and their activity decreases. So if we were to visualize how enzyme activity and pH are correlated, we know that they have an optimum pH, which is where they have their highest activity. And so you'd see a peak in the table. If the pH were to change away, so perhaps by being too low or too high, then you'd find that the enzyme is denatured and it won't function. So you'd find that in a graph, the rate of enzyme activity would be decreasing either side of an optimum pH. So when we come to understand, when we learn about the factors which affect enzyme activity, it's important to be able to calculate the rate of reaction. The rate of reaction is equal to the gradient of the graph, where you have a graph which shows the mass of the product, so how much is being produced as a result of the enzyme action, and the time. So the gradient is calculated by picking 2 points on the graph and then dividing the change in the value on the y-axis, so the change in mass of product, by the change in the x-axis, the change in time. So you're literally looking at rate equals change in mass divided by change in time. So if I were to use an example of change in mass of product was 10 grams over 60 seconds, when I do 10 divided by 60, I get 0.17. So the change in mass is 0.17 grams per second, and that's the rate of reaction. So as I've just mentioned from my example, that the units for rate of reaction are grams per second, and the rate of reaction is dependent on the mass of the product, and it can be calculated by doing this exact calculation I mentioned. So let's look at another example. A green tree produces 25 grams of a substance. So this is our product from the enzyme reaction in 10 seconds. This is the time. What is the reaction rate? So first of all, let's remember what the equation for the rate of reaction is. So we know it's change in mass, so in this case 25 grams, divided by change in time, 10 seconds. So if we substitute these into the equation, and when we divide them, we find that the rate of reaction is 2.5 grams per second. So just to recap on the factors affecting the rate of enzyme reaction, we know that there are two, and these are pH and temperature. Enzymes have an optimum pH, and if it is to increase or decrease on either side of this, enzymes will denature. And they also have an optimum temperature. Enzyme activity will increase up to this optimum, and then it will begin to decrease after. So let's think of another example for rate of reaction to make sure we've covered it fully. So let's say in a reaction involving enzymes, the change in mass is 10 grams and the change in time is 60 seconds. What is the rate of reaction? So we've got our change in mass is 10 and our time is 60. So we're doing 10 divided by 60, which is 0.167 grams per second. So let's just remember that enzymes have an optimum pH, and if it changes away, the enzyme activity decreases. Okay, so that's everything we're going to be looking at now for rate of reaction. Thank you for listening.